A simple random sample of size 63 is obtained from a population with mean 40 and standard deviation 10. Does the population need to be normal for the sampling distribution to be normal? No, because the sample size is bigger than 30. So the sampling distribution will be normal whether or not the population is normal. So no, we don't need the population to be normal. Central limit theorem states, regardless of the shape, the sampling distribution approximately normal as sample size increases. Yeah, so there's no mention of 30 in any of the choices. So the point of 30 is that the sample size should be large enough, and 30 is a commonly agreed benchmark. And sometimes if the 30 is missing, then you just choose a choice which says that the sample is increasing. Okay, so sample size 63 of population with mean 40 and standard deviation 10. Does the population need to be normal? No, so we've already answered that. So now you have to answer the value question. So let's see, the sampling distribution is normal with mean same as the original mean, which is 40. And the standard deviation, is the original standard deviation, which is 10, divided by square root of sample size. So square root of 63. Remember, the standard deviation was original standard deviation divided by square root of sample size. So we have 10 over square root 63, and that ends up being 10 divided by square root 63, and that would be 1.2, 3 decimal places, so 1.26. Okay, determine mu x bar and sigma x bar. So mu x bar is just the mu, 84. And sigma x bar will be the original sigma divided by square root of sample size, so square root of 64, and that will be 1. Mean 72, standard deviation 24. Identify the sampling distribution of the sample means for sample of size 36. So sample is bigger than 30, so the sampling distribution is normal. Mean is the same as the original, which is 72. And standard deviation will be the original standard deviation, which is 24, divided by square root of the sample size. So sample size in this part is 36. So that should equal 4. In answering part A, what assumptions did you make about the distribution? We made no assumption because the sample size of 36 guaranteed us the normality. So we did not assume that the sampling distribution is normal. We know that it's normal by central limit theorem. So no assumptions were made because the sampling distribution is normal regardless of the distribution. No assumptions were made because of the relatively large sample size. Yeah, that's talking about the 30, greater than 30 thing. The sampling distribution is normal regardless of distribution of the variable. Now, B is kind of saying that no matter what the sample size is, it would be normal. That's not true. Sample size has to be large enough. Can you answer part A if the sample size is 25 instead of 36? So we are not told anything about how the population is distributed. Therefore, in order to work the problem, we had to know that the sampling distribution is normal, which we did in part A because the sample size was bigger than 30. But if the sample size is 25, which is less than 30, then we can't say anything about the sampling distribution, and we have no formulas because central limit theorem does not apply in that case. Since population is also not given to be normal, and if the sample size is also less than 30, then we can't work the problem. So can you answer? No, we cannot, because the sample size must, so 5 has nothing to do with it. No, because the sample size needs to be at least 30 if the distribution of the variable is unknown. Okay.